So let's talk about execution time. Okay, so till now the problem that we have solved was just a 3 by 3 problem, okay, which involved 3 variables and 3 equations. But in real life, if you see, you'll be solving problem which has like million unknown and million equations. Okay, I'm not joking, it's real, it's a reality. And in FEA and CFD, if you see, you actually solve these kind of equation which has like billions of equations and billions of unknown. Okay, so at that particular time, the execution time is a very important parameter that we have to take care. Okay, and the execution time is directly proportional to the number of flops, where flops is known as operations, floating point operations. That is how many number of addition, how many number of subtraction, how many number of divisions. Okay, so execution time becomes very important when you are solving problems which has a lot of unknowns and a lot of equations, a lot of unknowns. So if you see, when you talk about Gauss elimination, the number of flop is approximately equal to 2/3 of n cube, where n is the number of equations. Okay, so it is what 2/3 of n cube. Okay, so till now what we have talked about is only Gauss elimination, but there is one more type of elimination known as Gauss-Jordan elimination. So we know in Gauss elimination what we do is we convert the matrix into an upper triangular matrix. Okay, so if we have a matrix, what we do is, let us say this is A, B, C, D, E and F. We try to make this element 0. Okay, but when you talk about Gauss-Jordan elimination, it is very similar to Gauss elimination. The only difference here is going to be, you are going to make this element 0, you are going to make this element 0, you are going to make this element 0. In addition to these 3 elements, you are also going to make this element 0, this element 0 and this element 0. Okay, and basically this is how you are going to perform your Gauss-Jordan elimination. Okay, so if you see, this Gauss-Jordan elimination takes somewhere around n cube flops, number of flops. Okay, n cube number of flops. So if you see, obviously if you see between Gauss elimination and Gauss-Jordan elimination, obviously Gauss elimination is much faster as compared to Gauss-Jordan elimination, which is n cube, and this is 2/3 of n cube. Okay, that was one of the reason why we don't generally discuss Gauss-Jordan elimination, because we try to eliminate more elements, more 3 elements. Okay, now this was just, we are talking about 3 by 3 matrix. Again, when you talk about real life, it will be n number of equation and number of unknown. So Gauss-Jordan elimination, if you see, almost takes 50% of more time as compared to Gauss elimination method. So that is the reason why we have not discussed Gauss-Jordan elimination. Now there is one more use of Gauss elimination that you need to understand, is for finding out determinant. Okay, so I hope when you talk about determinant, everybody here knows how to find out the value of this determinant. How you are going to find out the value of determinant? This is going to be A into minor f g j k minus B into e I g k, and C is going to be e I f j. So I'm not going to discuss how to find out the determinant in detail. If you are still not clear what I'm discussing about, you should just go check how to find out determinant from basic linear algebra. Okay, anyways, let us come back to this. So another use of Gauss elimination is for finding out the determinants. Okay, if you have noticed here, we have found out the determinant of a 3 by 3 matrix, or 3 equations. Okay, so if you see, still the determinant, the process of finding out determinant is actually complicated. Now this was just the problem where there was 3 variables. Now if you increase this to 4 variables, again it's going to be complicated. 5 variables, 6 variables, and let us say you want to find out the determinant of like 100 variables or 100 equations. So obviously finding out determinant is going to be again a very daunting task. So what actually we do here is we find out the Gauss elimination of the matrix and then find out the determinant. So basically what I'm trying to say here is, let me erase this here. So this is the conventional method of finding out. This is the conventional method of finding out the determinant. But if you have trying to find out determinant of equations which are huge in numbers, so finding determinant is complicated. So what we do is, I'm just giving an example of a simple system. Okay, and since it is a determinant, let us write it down like this. Okay, or else let us first write down a matrix form and then we'll move on to this. So let us say this is the matrix A, and now I'm using this notation for matrix. Okay, if you see tilde below the alphabet, that signifies it's a matrix. It's a matrix. So this is the matrix, and I want to find out the determinant of matrix A. Okay, I'm not going to use conventional method. I'm going to use Gauss elimination. Okay, so according to Gauss elimination, what you are going to do? You are going to make this element, that is your I. You are going to make this element, and this element equal to 0, 0, and 0. And now if you find out determinant, you'll find out that determinant of A is nothing but mere multiplication of the diagonal elements. Just try to put this in, just try to find the determinant of this using the conventional method, and you'll find out the determinant of A is nothing but A into F into Q, that is multiplication of just the diagonal elements. So this simplifies the method of finding out the determinant. Okay, so this is one very interesting thing that you should know. Okay, if somebody gives you a 4 by 4 equation and tells you to find out the determinant, so obviously I think as far as I know, in calculators you cannot find out determinant of 4 by 4 equations, and even if you follow conventional method, it will be difficult for you to find out the determinant. So what you are going to do is, you are going to go for Gauss elimination. You are going to try it, you are going to eliminate these elements, and just merely once you have done the elimination, you just merely multiply the diagonal elements. Once you multiply the diagonal elements, the product of those diagonal elements is nothing but your determinant. So I hope I have made this idea very clear to you guys.